right, everybody, this is the overview for Lab 9 on correlations. So this lab is a little bit different than the labs we've been doing in so far in that I have provided a data set for you, so you will not be inputting any of your own data for this lab. So what I have here, if I scooch my window over, so what I've done here is I've gone into VMware. I'm here in VMware in my browser. Then I've opened a browser in VMware. All right, I have Google Chrome open here. And I have our lab assignment page up. And here we have the link for the data set as well as the instructions. So I have my instructions up over here, and then I'm going to go ahead and open up this data set. And then once I do, we'll be running analysis on this data set rather than inputting data and running your own. So hopefully that's nice, that we don't have to slave over inputting data this time around. So while that's opening, let's take a look at what we need to do. So correlations are relatively simple. They compare two sets of scale or ratio data. So let me go ahead and scroll down here. So the first thing that we want to do is just run a correlation and see what we get as an output. So I have you run a correlation that we anticipate to be strong. So we're going to go into Analyze, into Correlate, and then run a bivariate correlation. And we're going to go ahead and try the variables height and weight. So this is a big data set full of all sorts of info here. Notice that we have lots of different variable types. We have gender, if someone's an athlete. We have height, weight, whether someone's a smoker, some health measures here, sprint time, mile duration. We have some educational, right, or ability-based scores here in English, reading, math, and writing, just among some others, all right, sleep time. So let's go ahead and try running that first correlation. So we'll go into Analyze, we'll go into Correlate, we'll go to Bivariate Correlation, and we're going to pull height and weight over here. One thing we ought to look out for here is that we can only run correlations on equal interval data. So any of these that have, say, ranks or categories, these are not going to work for correlations, right? We can't run a correlation between gender and anything else, right? Because we need continuous variables. So just keep that in mind as we move along here. All right, we're going to click into options and just get our descriptive statistics like means and standard deviations. We're going to click another option here, which is flag significant correlations. All right, flagging significant correlations is going to immediately tell you if a particular correlation coefficient or an R value exceeds the cutoff score that would be set for that particular test. So let's go ahead and press OK and take a look at what we get. So we have descriptive statistics, means and standard deviations. That's what we asked for in our options. And then here we have a correlation matrix, which tells us a few things. So if we take a look at this table and start to read it, we have height and weight over here, and we have height and weight over here. So if we look at the correlation between height and height, we have a perfect correlation of 1, all right? And that's what we would expect when we compare one variable to itself. But what we're interested in is the correlation between height and weight. So if we take a look at height and weight and our correlation value here, we see a correlation value of 0.513. And notice that we have two asterisks by that 0.513. So if we go down to the bottom of this table, it lets you know that that means that this is significant at the alpha level of 0.01. In fact, the significance value here is 0.000, so less than 0.0001. All right, so that's good news. That's our first bivariate correlations. Let's go ahead and see what else we want to do. So here's a bit of an explanation on that here. It's significant. All right, so let's go ahead and try something else. We're going to try something called a partial correlation. Partial correlations control for an additional variable, and this can be a non-continuous variable. We can say control for somebody's gender when we're comparing height and weight. So we're going to go ahead and do that. We're going to control for a few different things here. So we have our instructions here. So let's go ahead and do just that. Let me get our output out of the way. So we're going to do an analyze, correlate, partial correlation. We're going to keep up with height and weight. And then we want gender, athlete, and smoking over here in our controlling for. and we will get means and standard deviations again. So let's go ahead and press OK here. Then we have our descriptive statistics for these here. Of course, means and standard deviations for coded data is not going to help us out too much. But more importantly here for correlations, now we have correlations controlling for gender, athlete, and smoking. So you can take a look here. We do appear to have significance here, though they were not flagged in the same way since we didn't choose to flag them. All right, so if we continue on down, we want to take a look at some more correlations, all right? So we're going to try running multiple correlations at once. We're going to go back to bivariate correlations, and we're going to add, in addition to height and weight, some of our other continuous variables, and we will look at all of them at once, and it's going to make us a big, big table. So let's go ahead and give it a try. We're going to do correlate, bivariate, and we're going to pull in, let me get them all here, this list of continuous variables. Remember, we're only using these scale type variables. Let's go ahead and pull these in as well. Let's see if I want you to grab anything else. We want to flag significant correlations. All right, so let's go ahead and run this guy. All right, now we have a very big, kind of daunting table here. So let's take a look. Let me get my window a little bit bigger here. All right, so we have lots of correlations now, and this is not uncommon to do in the research context. Maybe we want to run correlations between 10 different behavioral measures and 10 different physiological measures, and then we would have a correlation matrix of about this size. So what you want to be looking for here, this is where these asterisks come into play nicely. You can look for these asterisks on these correlation values to see which of these relationships are significant. So taking a look here, if we're going to look, say, at this one here, we see that there's a correlation between weight and math ability. Okay, a little bit strange, but we'll take it. Notice this is a very weak correlation. Correlations range from -1 to +1, 0 meaning no correlation. So this would be very, very weak, as with this one here, which makes sense, right? These do not seem like they would have an inherent relationship. So let's go ahead and pop back over here. The next thing that we want to do is plot the data, plot some of these correlations. We specifically want to plot a significant positive correlation and a significant negative correlation. So this will be up to you to find in this table, so I will give you a couple of examples. So we're going to go to the Graphs tab, to Legacy Dialogues, and then to Scatter Plot. And then we need to determine which variables we want to, say, pull into this particular graph. So we need one positive relationship and we need one negative relationship. So we can start by just looking for asterisks, right? We have 2 asterisks here. So height and weight was significant, right? That's a significant positive relationship. Or if we go down here, right, here's another strong one. This is our mile-minute duration and sprint time, right? Those seem as though they would be related, and we see a strong relationship here. So you'll want to create a scatter plot for one of these positive relationships, but you will also want to create one for a negative relationship, and these are a little bit harder to find, but we do see a few of them in here. All right, here for writing, we see a negative one, writing and height, again, sort of a weird relationship, but you'll want to seek out one of these negative relationships, all right, something like perhaps weight and mile time, and you will want to plot one of these. So I'll go ahead and plot one of them, and then I'll leave the rest to you. All right, so here we are. We want to do a scatter dot plot. So let's do a simple scatter plot. I'll just go ahead and do, where do we have them? Height and weight. So I'll pull height into my y-axis and weight into my x-axis and press OK. And it will generate a scatter plot for you with all of the data. And remember, this is a pretty large data set, so it's going to plot all of the data for you. All right, and with that, you're going to add a line of best fit to these graphs. Editing graphs in SPSS can be a little bit tricky, but if you double click, you get a graph editor, and we're looking for a line of best fit, which is going to be right here, add a fit line. It's going to ask you what type of line. We want a linear fit line, as we discussed in the lecture. Not all co-relationships are linear, but this is what the test is designed to detect, right? If we find, say, a quadratic relationship, that's a little off the mark for this type of test, but no less we can detect them and decide to run, say, a different test. So we'll go ahead and close out of this, and we have our fit line here. If you close out of the chart editor, it will keep that fit line for you on your output. All right, and with that, there we have it. You will be creating 2 scatter plots total, one for a positive relationship and one for a negative relationship, and make sure that you have your correlation tables, as well as mean and standard deviation tables on your output. So that concludes the overview for this lab. Be sure to be in touch if you have any questions.